This video is presenting the Autosteer technology by AllyNav and imported by myself in Canada. Autosteer technology for tractor means you have a monitor, an electric steering, antennas on the roof of tractor, and because we're using RTK solution, we need to have somewhere in the neighborhood a base station. A word on myself. My name is Jean-François Ridel. I have an engineering degree from the ETS of Montreal. I also worked for 10 years in Japan doing GPS application, mobile phone application, and TV programming kind of things. But since 2008, I moved back on the family farm in Quebec. And I'm also involved in various organizations related to farmers, such as the Farmers Union of Quebec and the Grain Producer of Quebec. So Autosteer, why would you want to have Autosteer? There's so many great reasons on an agronomic point of view. Whether you want to do some crop positioning, look at this. You've got the current year planted here, and the last year was right there. So it's just a small offset you're doing on the GPS, and here you go. You can plant at the right location anywhere in the field. This could also be true for positioning your fertilizer or doing some zone tillage or ridge tillage. This is a ridge tillage happening on my farm. And control traffic farming is also something very important to improve your soil health. Again, Autosteer is a must to do it. And we can't forget about operators' fatigue. Having an Autosteer gives you free time to double check your implements and make sure everything is working perfectly around the tractor. Now, what do you need to do that? Of course, you need to have an accurate GPS, something reliable, easy to use, and which is going to last long enough for the investment you're putting in. AllyNav is all about that. It's affordable, it's reliable, and let's see it in action. Here we go. This was actually a few weeks ago, no, just last week, where I was doing some chisel tillage, and you can see the accuracy. We're in the 1, 2, 3 centimeters considering the drift we have behind the tractor. I think it's pretty cool, it's pretty good. And the point here is just like a zone tillage, we're tilling the soil where we're going to be planting corn next year to have a mellow root zone for the corn. A word on the GPS technology, actually, where does it come from, and a bit of history as well. Shall we call it Global Navigation Satellite System, which is the more generic name for this, while what actually GPS is the most known word. So a GPS system relies on having constellations of satellites The most known one is the American one, which is the GPS, and this is what we're seeing on this picture. We are expecting to have something like 8 to 11, 12 satellites above our head that is sending some timing signal. So it's a super accurate timing signal which is sent from the satellite reaching ourselves at the speed of light, and knowing that speed, knowing that the timing it started, it arrived, we can compute our exact location. So on a flat world we need to have 3 satellites, but of course we need more than that to be more accurate, to be more reliable as well. So we've mentioned about the GPS from America. The Russians have the GLONASS constellation, the Chinese have Beidou, Europeans have also Galileo. And what does it mean for us? This is more satellite available to give us more a little bit of accuracy, but also more reliability. It means that if you're losing a constellation or if you're losing a satellite, which is more the common thing happening on the farm, is especially when you're passing by a bush or trees, you're losing a few satellites. And if you only have a GPS only, so a one constellation system where you're relying on, let's say, 8, 9, 10 satellites, and you lose 3 or 4 of them, then suddenly the system is not stable enough. But having, just like what AllyNav is proposing you, where we have about 30 satellites available, well, 30 is maybe in the best case, but no, it varies from 20 to 30 satellites available above our head. It gives us a stability of system in most conditions, which is awesome. Well, a word on frequencies. See here, if we only look at GPS, they are broadcasting at least 2 frequencies that are widely used, the L1, L2. L5, I believe, is more for the militaries, so we don't care. And this is going to be important in a slide or two. So the satellite are broadcasting signal, and as the signal passes through the atmosphere, it slows down a little bit, or it bends a little bit. It's pretty much like the light passing through this prism, or even better, the light passing through this other triangle prism. And what happens here is that light separate from each other. Well, what this means is those different colors are different frequencies. And remember, on the previous slide, we had various frequency from a same satellite. This means that we can understand a little bit better how the signal have passed through the atmosphere. So this is a little bit more accuracy available for GPS. Well, even though this is far not enough, so we need to have something even better to drive our system, because a standard GPS is probably like a meter or 2 of error, which I mean by the, well, just look to your mobile phone. This is like 1 or 2 meters offset is common, but in a tractor, we need to have this centimeter level of accuracy, and what we need is RTK. RTK works with a base station. That base station is at a known and fixed location all the time. It measures its own location, therefore finds out any errors that would come from those satellites. Knowing this error, it can be sent to the user, or in our case, our tractors, so that we can measure this accurate location at all time within 1 or 2, or not even 2 centimeters. Now this information have to be transported from the base station to the tractor, and to do that we need to use whether an FM transmitter, some internet link, or satellite solutions. All these families of solutions have pluses and minuses. Let's say that the FM radio, it's a one-time cost. It's widely used, at least in my area, from John Deere. Also for my Ag Leader receiver also is using FM radios. Mobile technologies are bringing new features such as wider coverage. You're not limited to the coverage from a mobile as long as you have a good coverage of mobile phone, of course, and this can be an issue, so you have to know whether you're getting a good coverage in your location. Well, I'm just putting Wi-Fi in case you'd have a small enough farm to have a Wi-Fi connection, which would save you the cost of the mobile link. And we are not supporting these technologies as for AllyNav right now, but if you look to Trimble, John Deere, and they all have satellite kind of similar to RTK technologies. They call it whether OmniStar, SF or Starfire, and TerraStar. These functionality have different legacies. In the case of OmniStar and Starfire, they're getting rather old, and the technologies they're using tend to be very slow. So you may need to wait as much as 30 minutes in the case of OmniStar and Starfire to get actually an accurate positioning, which is annoying, of course. TerraStar X came up with something pretty cool. It's super recent, and they're claiming to have near RTK speed and near RTK accuracy as well. So I'm looking forward to see how actually this is good. But back to what AllyNav is proposing here, it's mainly through mobile link. The other advantage I see from mobile link is it's much cheaper than any satellite subscription, and it also gives you an internet link. Therefore, if you want to get information from the weather station, or if you need to have some, well, there's a few internet services that are already linked to the AllyNav's platform. Therefore, these mobile links are much more flexible. So let's review a bit the solution. We need to have two antennas on the roof. We have the monitor here and electric steering, and super important is to have this angle sensor on the front train, and we'll get to that in details in a slide or two. And oh, you get a backup camera as a bonus. The monitor is rather simple. You have the system configuration on the left, the statuses on top, the AB line and the Autosteer start on the right side. Inside the monitor, well, it's a ruggedized plastic case with a solid silicone gasket, and here's the Android tablet board, which is a very common technology. All the connectors are glued to make sure it wouldn't be disconnecting through vibration. Of course, we're in a ruggedized environment. In the case of any leak, there's some silica humidity absorber, and right in the middle, here's the heart of the accuracy of the solution. It is a high accuracy GPS receiver, dual antenna by Unicore Com. So two antenna or one antenna, which is best? Well, sure enough that most of the manufacturers are going for single antenna. It's smaller, it's easier to install, probably, but two antenna happens to be more accurate. You get from the first fix the right orientation of your tractor, and it's also better at low speed. So if you're a vegetable producer, you definitely want to go for a dual antenna solution. AllyNav actually have their flagship solution with dual antenna, just to tell you. Just so you understand that the single antenna version, they're using an accelerometer and a gyroscope, and these technologies are susceptible to vibration, and this is why at low speed you might have some issues. Those vibration are making these drifting a little bit. The steering. Well, if you look at any GPS ready tractor today, they're all equipped with electro valve. This is an awesome technology, but it's also a little bit costly. It's complex to install, especially from an aftermarket point of view. From aftermarket point of view, to simplify the connections and believe me, installing an aftermarket electro valve is quite a pain in the ass. So this is why all the main manufacturers are providing electric steering today, and it actually works okay, so as AllyNav. So here's an overview of an installed system. You see those two antennas on the roof, the angle sensor here, the electric steering, and here's the monitor with its electric steering. But let's get back a little bit on the angle sensor, right? So we said that the GPS ready tractor have an electro valve, but they also are using an angle sensor, and this actually is why they're more accurate than the steering only solution. So in the case of AllyNav, to ensure that we're delivering this high accuracy from day one, we are requiring to use an angle sensor. It's actually the most complex part to be installed on an aftermarket system, but it really worth to do it, because this is what actually makes the system as accurate as if you buy a GPS ready tractor today. So the issues are that if you leave a cable pending, like here, it could be smashed by whether a crop, a branch, a rock, mud, so this is not so cool. You may want to have to deal with some dirt. So these are all issues that make this installation a little bit complex. Usually you can think of spending like from 1 to 3 hours to get this installed properly. But again, it's really worth to do it, and this is what brings high accuracy to the system. In some cases, the pivot is just not accessible, so we can go for a lever and rod angle sensor. It works pretty much the same. But on a geometric point of view, the angle sensor installed right on the pivot would be better, but in some cases it's just not possible, so we go for this setup here. A word on the company. AllyNav's been in business since 2015. They are growing pretty fast. They have 5,000 systems installed so far. And it's growing faster and faster. They're covering, I think it's 60% of the Chinese market. So they're #1 GPS Autosteer provider in China today. They also have a nice roadmap. So we should hear from yield monitor, land leveling systems, and even more to come. So things you have to keep in mind for this solution are we have a high accuracy system because of the dual antenna and the angle sensor on the kingpin. We have a super simple, low cost monitor, and there's more feature to come, like counterline, field logbook, spare section control, land leveling features as well. Here's another video. It's beautiful to see these things running. I was driving my tractor, doing some disc tillage earlier this spring to chop off some corn stalk. I see the accuracy. We're driving at near 20 kilometers an hour. There's some drift due to the disc configuration, yet the system was pretty okay. A last word that I'm also marketing laser solutions. So if you're doing some excavation, land leveling, tile drainage installation, here's a few products that might be helpful for you. Please get in touch with me by phone, by email. I'll be more than happy to answer a question by the best of my knowledge. And well, talk to you soon. Thank you for your time, and I hope you enjoyed this video. If you could like it, it'd be much appreciated. Have a good day.